So now at this point of the video series, I thought it would be a good idea to take a Zener diode and an NPN bipolar junction transistor and wire them up so that they turn a load off, in this case an LED protected by a 470 ohm resistor, when the supply voltage drops low enough. So I decided to make this for a 9-volt lithium ion battery, which means it's actually not 9 volts. It only charges up to 8.4 volts. The charger takes care of that for you. You don't have to worry about that as long as you use a proper charger. But just be aware that if you use one, you're only dealing with 8.4 volts, which goes down as you use it, just like any other battery. So, in any case, you can see we got 5.6 volts before that Zener diode will conduct, and then about 0.6 volts before the base 2 emitter will conduct. So, we got about 6.2 volts total. But even if you have a low voltage, there's a little trickle of current. It's very small. But again, the NPN bipolar junction transistor is an amplifier. Even a very small trickle will allow, much more current, even though it may not be a lot, to flow from collector to emitter. So we have a 10K resistor there to help get that trickle of current to ground instead and keep the voltage low enough where we should cut that off completely right there. But we still have to limit current when the voltage is high enough. So a 4.7 kilo ohm, 4007 ohm resistor should do that. But any case, the 9-volt lithium ion battery, 8.4 volts, really should stop being used somewhere about 6 volts, 3 volts per cell. Each cell is fully charged to 4.2 volts, and you can discharge it pretty nicely to 3 volts per cell, or 6 volts total. If you drop below 5 volts, that's when you risk damaging that. That's when both cells drop below 2.5 volts. The chemistry gets messed up. They might catch fire the next time you charge it. So now I'm not going to use the battery for the demonstration circuit. That would probably take me half a day to make the video. Instead, I'm just going to simulate the voltage dropping with the power supply. So we go down to 7 volts. The current's mostly going down because there's less voltage powering the circuit. But now we're going to work our way down and see when it actually fades off. So we can modify it so it might work a little different. So it's not on fully anymore. But now it looks like it's off almost completely. There's a little glow, and we are off there. So there's just very little trickle going on. Battery would last probably forever at this point. So in any case, we're just keeping this short. Just a quick demonstration video of a circuit I think is fun.